In today's audio episode, we discuss how one Canadian refinery tackled the challenge of converting to renewables, the critical metallurgy upgrades involved, and how high-velocity thermal spray provided a faster, more cost-effective alternative to welding, delivering long-term protection with less disruption. The former refinery in eastern Canada was performing a site-wide conversion in preparation for firing renewable fuels. The Canadian government was partly financing the conversion. The refinery started processing sustainable aviation fuel in summer 2022. Using sustainable aviation fuel results in an up to 80% reduction in carbon emissions compared to the traditional jet fuel it replaces over the life cycle of the fuel. 2 reactors and 2 drums required a metallurgy upgrade due to new operating conditions. With renewables processing, reactors are susceptible to high temperature, free fatty acid corrosion, sulfidation, wet chloride corrosion, and stress corrosion cracking. The drums had possible damage mechanisms, including wet CO2 corrosion, wet chlorides, and potential ammonium hydrogen sulfide and ammonium chloride. Upgrading the metallurgy can be achieved via automated welding or high-velocity thermal spray. The refinery, in conjunction with their EPC, have contracted integrated global services to apply thermal spray cladding. Jason Lin, IGS Asset Integrity Specialist, said they saved half of their cost comparing to automated welding and a third of their time. Another reason why they didn't choose automated welding was the fact that IGS doesn't have to preheat the material for the thermal spray application. This was important as the facility is in Arctic conditions. The facility appreciated the fact that IGS could work turnkey. They didn't want to have multiple vendors performing different tasks, with one group doing preheating, another group welding, with a third group potentially doing the post-weld heat treatment. IGS worked turnkey and performed blasting, provided ventilation, applied thermal spray, and inspection services. Furthermore, much higher deposition rates, without dilution or needed butter or intermediate layers to achieve surface chemistry, make thermal spray a better choice over welding applications. IGS designed and specified 2 different alloys for the drums and the reactors. Nickel chromium molybdenum alloy type material has been specified for the reactors due to its excellent resistance to chloride corrosion, stress corrosion, cracking, and sulfidation. For the drums, a nickel chromium molybdenum alloy material was specified for its proven corrosion and erosion resistance. The EPC, asset owner, and the licensor required a comprehensive pre-qualification and adherence to a tight engineering standard to govern the quality of the cladding applied and ensure that the thermal spray protection would hold up against the new harsh corrosion mechanisms. Tests were performed at the IGS state-of-the-art laboratory in Richmond, Virginia, to alleviate any concerns. Ian Hall, IGS CTO, said, "While material selection is important, it is only a small part of the technical package required to ensure durable long-term performance in cladding systems. Careful attention to surface preparation and accessibility, utilization of a high-velocity process, and critical parameter control is necessary to ensure homogeneous alloy cladding with the right mechanical properties. It also takes more than a coupon to qualify an application. Management of environmental conditions and monitoring of field quality control with real-time production test plate assessments is also required." IGS delivered an engineering package including the project plan, method statement, inspection test plan, project safety analysis, risk mitigation plan, and the job-specific safety data sheets. The project was completed in over half the time the plant estimated weld metal overlay would take to execute. IGS, together with the refinery and the independent inspector, have carried out a thorough cladding inspection 4 years after its initial application. All thermal spray cladding, including the tie-in areas, was found to be in as applied condition with no signs of delamination, degradation, or metal loss. Application time for thermal spray is X days compared to 3 times days for weld overlay. It results in no heat affected zone, higher alloy metallurgy in most cases, and no dilution into the base material. There is no stress or distortion to the substrate. Repairs can be performed by blasting out, with fewer man-hours impacting turnaround. It forms a mechanical and chemical bond and allows sites to skip maintenance cycles. It is considered a 10-year plus solution. Weld overlay, by comparison, has a heat-affected zone, limited metallurgy due to base material combination, and involves dilution into the base material. It can cause stress and potential distortion of the substrate. Repairs require grind out and can be lengthy and costly. More man-hours and crew are required on site. It forms a metallurgical bond, and while it can also skip maintenance cycles, it typically takes longer and involves more execution risk. It is also considered a 10-year plus solution. Welding alternative achieves 50% savings in renewables conversion. And that's it for today's episode of the Efficiency and Reliability Podcast. Next week, we'll discuss a major inspection at a U.S. power plant and how proactive surface protection prevented a full shutdown. See you then.